Thanks, guys. The nut behind the wheel. I was sitting at the table there with Bill Costello, and he said it could be the nut behind the microphone, so we'll find out how that goes. It's an interesting exercise when you start talking about human error, because the one thing about it, guys, that we are all human. We all make mistakes, or we make decisions that are not always the right ones, and learning how we can manage that is an important part of it. But I'm going to show you something now. When you start thinking about the human error part of it, it's a fairly serious and important thing we need to consider. And some of the questions, the points I'll pass today will go really to looking at Liz Bluff's presentation earlier this morning. I'll answer some of her questions and points she raised. But when we start looking at human error, this is a good venue. This is a guy who's riding his motorbike and he's texting as he goes along. So it's a good little sign. Or you can get another guy. It's a little bit. This is one of Chris Ellicott's, by the way. He put this together. But this new hands-free phone. So it all adds to the fact that we, as humans, we do tend to do things a little bit differently than most other people, and we need to understand why they happen. But coming back to the point, Mark Twain said that man is the creature made at the end of the week when God was tired. I think there's another part of that too. A woman was made on the last Sabbath. I won't go down that track. And Jim Reason, who's a fairly influential part of the industry as far as human error is concerned, put a point on so that if you don't manage human error will manage you, and that's an important part. And I think if you go to most of the accidents, for instance, we have in the mining industry today, human error will play a major part in all of those we have. And if you go to the next slide, it says here that human error directly contributes to around 80 to 90% of all of our accidents. So it's an important subject we need to understand and address when we're looking at how we develop and design our equipment or our machinery and so on. If you consider the full life cycle of equipment, then human error can probably be found in most of those accidents. So it must be recognised and addressed as part of any design, any procedure development, that the human can fail and will fail the majority of the time. When you're looking at human error, we have a situation that there's only one certainty, that human beings will make errors, guys. We all do, and I can guarantee if anybody in the room hasn't made an error, can they put their hand up, and I'd like to come and shake it, because I think that hasn't made. Well, there's one lady at the back that says she hasn't made an error. Are you married? Well, I'm not going to go there in a minute. This is a good one. These guys are all suited up, and he's standing there looking at this, and you think, so, well, God Almighty. But I do know the background of this. This guy was actually an assessor at a competition, so he's watching what the guys are doing. So it's not a real action, but it makes you look at it and you think, God, oh bloody mighty, you know. You can imagine him walking up and saying, what's going on, guys? And you look at this sort of issue here. So errors are different at different times. So what can we do about errors? We need to become part of risk management. We need to design systems that the likelihood of human error is minimised. You can't take it away altogether, but minimised, and the consequence of human error is reduced, or manage the risks arising from humans, understanding what they can do wrong and how they can achieve it. And if you put it into your risk management process and just accept the fact that the human will err at certain points in time, it's an important process as you're going through. We've all seen the good old NERTY wheel. Competent people, fit for purpose equipment, adequate procedures and so on. This is the typical human factors tool. But what it also says, for all of those to happen, all of the components of the NERTY wheel require one thing: people. It's when we do the people processes that we get people that get hurt or get injured. Now, there are three types, from Jim Reason, three types of human error. There's slips and lapses in concentration, where you didn't do it deliberately, or there's mistakes, where you deliberately intended to do something but you did it wrong, or there are violations where you break the rules. Now I'm going to ask a question. How many people in the room have been booked for speeding? Yeah. How many people in the room have been driving along the road and you see a police car parked? What's the first thing you do? Look at your speedometer, don't you? Think, oh shit. So how many people going down the road have been booked for speeding and they didn't realise they were going too fast? You just rather think, oh shit, it's just accelerated a little bit. So you've had a slip or lapse in concentration. Would that be a fair call? How many people have been going down the road and been booked for speeding? What's the policeman going to get you for? A violation. You've done the wrong thing, he's going to book you for that sort of thing there. And you can make mistakes as well. So we can all slip or lapse into concentration. We can make mistakes in the way we set procedures. And the police will look at it, at that error as a violation. So all three of them could come into play at different points in time. For the slip or lapse, though, when you start looking at it, it's usually a physical. You know, for the slip, you can trip in the wrong movement and so on. Or lapse is usually mental. But when we look at both of those, the unintentional error, it's not intended to do, but it's an unintentional error. It's a slip or lapse in concentration. We've all had that. With a slip or lapse in concentration, when you're listening to the radio, you're driving down the road, you look at the police car, and you look down and you think, shit, I'm doing 125 kilometres an hour. And you're gone. So it's as simple as that. That's a slip or lapse in concentration. A mental error, you might misread the sign or do it wrongly. So you've done the slip and lapse and it goes through. They're unintentional errors. I want you to quickly look at this, guys, and let me know which one you think, which is the higher reading, left or right? Who got it? Which was the higher reading? Left or right? Left. So we quickly looked at a gauge and you made a decision which was the right one to look at. Because it was an unintentional error. You've looked at something there and you think, right, I know which one. Because the one is on the higher side, it looks higher, gives you the reading of a higher, when in reality it's not. The one on the left is a higher pressure on the gauge, which is an error that can be designed out as far as the engineers, when you're putting things together, where your gauges and so on. Similar to the gauge, the cylinder that blew up at Bulga in '95, where the young tradesman was killed on the filling the fire suppression system. The wrong gauge was fitted in the system. He looked at that gauge, got it wrong, and the pressurised blew up and unfortunately killed him. So when you start to look at these types of things, these can be engineered out and can be made a lot easier to follow. Some of the responses to slips and lapses is that you need to consider human factors when you're designing your equipment and putting your gear together. You need to design error-forgiving controls, things where you can't make the mistake. And in the ergonomics world, these things are there, that you can look at them up and you can get them out of textbooks about how you put your design your controls into place. And fortunately enough, or unfortunately, whatever, I'm married to an ergonomist, so my house is the most safest house you've ever come across. Sometimes. And you can look at the standards for safety of machinery, because they're important. If you do follow the standards, a lot of these things are designed to be error-forgiving. They're designed so you can't make the mistake. What we tend to do now is we wait till we have an accident of some kind, and then we retrofit something to prevent it from happening again. And that's not the way. We need to get that forward to that first and start to put it in the actual design. And the little point down here at the bottom is that the training is unlikely to be effective to prevent slip or lapse. You can't train people not to slip or lapse in concentration. It's not something that happens that way. So it's not a control, for want of another term. For mistakes, the intentional error. This is when somebody intended to do something, they wanted to do the job, but something's changed and they got it wrong. They made a mistake in doing that sort of stuff. Right? So they wanted to go and do it right, but they've got it wrong. It may have been incorrect for the circumstances of what they're doing, but they did it that way anyway. And it may have been correct in other circumstances, like maybe a job they've done 3 or 4 times previously, but something's changed in the system now that makes it you don't do it that way, and they've gone through and followed it up and done it the same way they did in the past, which is now wrong, and corrected them and made the mistake. Some of the responses to mistakes, adequate procedures, safe work practices and so on, job instructions, proper training, it can help with, so that the decision-making process is formalised when they go through it. Adequate supervision, to make sure that people are doing what they're supposed to be doing, and we can make sure that they are following the procedures and so on. Hazard awareness, they can understand what the hazards are associated. And the new one now that's looking at this situational awareness, it's a different type of term. I've heard it mentioned a couple of times this morning. And that's a little bit different than hazard awareness. This situational awareness is what's happening around you. What happens in your 2-metre circle? The things that, can it hurt me, can it fall on me, can I get trapped in it, can I get caught on it, and so on. That should be discussed when you're doing your engineering design, about if somebody's working in that envelope, and as in the ergonomics process, what can happen to them in that area, in that situation where they're standing, whether they're operating a particular gear, whether they're driving the gear, and so on. It needs to be managed and worked out that way. So situational awareness is another process to look at. Violations is another thing. If you're speeding, you're violating. Is that a fair call? You're violating your rule. I've just bought a new car, and it's a little bit quick, this car, and the sad part about buying this car here, it wants to go fast. It tells you it wants to go fast, but you've got to drive it to a speed limit that you don't want to speed limit, and so you intend there. But the thing that fixes me up there is this wonderful thing called cruise control. You get the cruise controller now, and it saves a lot of speeding fines, I'd imagine, to get through it. But we want to do things, we break rules, but not for all sorts of reasons. And one of them is that sometimes we break the rules because we see it as an advantage of getting things done better. The guys go underground and they have to follow procedure. It takes a little bit longer to do that. And I'll give you an example of this intentional and error type stuff. I was at a mine recently, and I go to this mine quite regularly, and I'm underground, and I come around the corner, and there's two guys in a bucket of an IMCO LHD, and the driver there, and I'm the safety consultant from hell. And I come walk around the corner, and the guy's operating the machine. He goes, "G'day, Jim, how you going?" Not too bad. Looks up the blokes, and all the blokes look at me and say, "Oh, shit." "What are you doing?" I said, "Oh, we're just pulling a couple of pipes up here." So, right, a couple of pipes, right. "Can you put the guys on the ground?" Put the guys on the ground. I said, "Is there a platform in the panel?" "Work platform?" I said, "Yes, it is." "So where is it?" "It's around the corner." "So why didn't you use it?" "No, it's only going to take 2 minutes to put this pipe up." I said, "Well, I might take that platform away from you." That's why I said, "Well, you don't use it." I said, "Now, if you were up in the bucket, somebody fell out of the bucket, and you didn't have a platform, what would be the first thing you'd be yelling at?" "You should have supplied us with a platform." "Well, we've supplied you with one, but you're not using it." Now, that's the sort of the errors you've got. They're intentional errors, but they're breaking the rules, and it's not meant to be that way. That's what we need to manage out when we put these programs together. Some of the responses to violations, and these are everybody's problem, guys, these violations, because there are, if you think they're not happening in your workplace, then you're running around with blindfolds on. You do really, because they do happen. People need to understand the true risk. And by saying true risk is what can happen and what can go wrong. We need to reduce peer pressure. And this is a simple thing to say, but a hard thing to do. And because what happens when we get into I went to another mine down the Illawarra quite a few years ago, and I went underground with 6 guys, it was quite a few, on their very first ever day underground. And took them to the face, and the thing that blew them away the most was the noise at the face. Miner cutting coal, vent fans going off, roof boulders, and the bloke said, "How the hell do you put up with this shit?" And yeah, you give them the PP. You go back 6 weeks later, and those guys are all working down that face now, and not one of them have got their ear protection, because that noise has now become normal noise. It's an everyday thing they do all the time. And they've gone away from this thing because people say, "Oh, you don't wear that hearing protection shit, it's a load of bullshit." And then the argument said, "You can't hear the roof working," you know. But the peer pressure pushes onto these guys, and they're learning to lip read. And lip reading is a good option. So, because in about 10 to 15 years' time, if they're doing it, they'll probably need to lip read. Need to stop people from cutting corners, because again, that's a shortcut. Get the job done quickly as possible. It's inherent in all of us that we want to make sure we get the job done as quickly as we can, I'd like to say as safely as possible. But if there's an easier way of doing it, humans will do it. They'll find the easy way to get out of things. And we all do that in our own lives, even at home. We should promote the involvement in the following the rules, the rule of involvement, that we say that we do, if we have a procedure we need to do, we need to follow that procedure. I mentioned it earlier too, we need effective supervision. And that's an important part. And when we say, the question you could ask is, what is effective? Is it regular supervision, just going down to see what the guys are doing? Or is it, one of the terms we used this morning, I think it was from our military friend there, about leadership. It's not just a case of saying that I'm the supervisor, I'm going to go down and check on what you're doing. It's how we lead our people and how we make sure we get the proper processes through them and so on. And have appropriate discipline. We used to have a culture of many years ago, and I'm sure Rob Reagan would have remembered this one, where initially, before the legislation came, we had a no-blame culture where we could do accident investigations without blame and so on. Well, that's fine, but in certain circumstances there has to be discipline that we come through. And we have to instill values in our workforce, that they know the rules are there and why they have to follow them. So, we have a bit of a fault tree. We have human error. It's either unintended, with a slip, which is mainly a physical type slip, trumbles, fall over the shoes and sort of stuff, which is easily detected. We have a lapse in concentration. Usually it's a mental concentration that you lose there, forgetting something, which is harder to detect. We have an intended human error, which leads to a mistake. People have done things, which could be a rule-based mistake, which is not following a procedure, which could be a skill-based mistake, which is a familiar task, they're doing it all the time, now it's changed, so they've made that mistake. Or it could be a knowledge-based mistake, which is they're winging it. They think they know all the procedures, all the jobs, and just going to go on through the process and do it. And then we have the violations, which are a cultural violation or a deviant violation. Now, the cultural violation is the way everybody does it at the site. We've always stood in the bucket of an IMCO, just the way we do it there. Well, the deviant violation is where they know the rules and they've got the platform alongside it, but they don't do it. That's a deviant violation. They've actually done that process and they've changed their minds. And when we start to talk about this, the just culture, in other words, this is where human errors can sort of come into play in another way here. It's a culture where people are valued and held accountable, where they have to be brought into line if they do it right or wrong. But we need to distinguish between the different types of behaviour. We have the acceptable behaviour, where people follow the line of company policies and procedures, and they know what the rules are and they follow them. That's our desired one. We have the human error, which is still acceptable. Slips and lapses are honest mistakes. We do lose these sorts of things, guys, and nobody's perfect. Well, I've been led to believe that. Nobody's perfect, but you know. Or we have doing it wrong. Needs to be admitted where people can put their hand up and say, I've made a mistake. And I'll give you another example of that. I was at an open cut mine quite recently, and I just happened to be on site there where they'd had an incident where a lady truck driver was driving along the haul road. It wasn't going particularly fast, it was a dry section of the road, and she skidded off and gone into a centre bund. And she actually called up a supervisor and reported it. So we go down, and the initial reaction was that she was going too fast, and so they did the drug and alcohol testing, and she passed the whole lot, so everything was fine. And when they sent her back to work, I went back to her into the crib room with all the guys, and the guys working with her give her a hell of a hard time. Said, you bastard, you stuffed my day up. Instead of a nice long haul road, they closed the road for the investigation, and now we have to do these short runs, and they're giving the girl a pretty tough time. And I asked the question, I said, you know, guys, you need to give her a 10 out of 10, this young lady. So I said, she put her hand up, and said, if you look at what happened was, the road was on a slight camber. There was a wet patch there, where she'd come around the corner, she wasn't speeding, she was there, she touched the accelerator, it's on a bit of a skid and run into the centre band. But she actually put her hand up. I said, in this crib room, I said, there's a lot of guys in this room, if you could have just backed out of that centre bund and drove away and not told anybody, you'd have got away with it. She put her hand up and said, I've learned something here. So this is where the philosophy of if you've done something wrong, people need to be thanked or promoted for putting their hand up and letting what they go through with it. Then of course we have the unacceptable, which is reckless behaviour, conscious or known disregard of accepted agreed rules and standards. And those sorts of people, then that's where your discipline procedure comes in. You can't have a no-blame philosophy if it's just reckless and negligent when people are doing something wrong. Now Jim Reason put up a fairly good format of just culture. It's an atmosphere of trust in which people are encouraged and in some circumstances even rewarded for providing essential safety-related information, but in which they are also clear about where the line must be drawn between acceptable and unacceptable behaviour. There is a line in the sand there. Some you can live with and some you can't live with. A lot of the operations now at the mines have got what we call golden rules or cardinal rules and that sort of stuff. That's the line in the sand for those guys. If you breach any one of those rules, then it's usually a dismissal. But they've drawn that line, and that's where they go through. I don't always agree with that process, mind you, because it can lead to other issues. But what tends to happen, we commonly go to a knee-jerk reaction. We have the fixes that fail. We have a problem on the site. We diagnose it and analyse what the problem is. We write detailed procedures, add complexity to the job, slow the job down and alienate the workers. So we've done nothing to resolve the problem. Or we go down the other side of the track. We discipline the worker. We reduce trust with the workforce. We get less flow of information because I'm getting in trouble all the time, and we've still got a problem. So these sorts of things don't change anything, guys. And in the human error part of the world, we have to make sure when we put procedures into place that they are easy to follow and designed out so they don't have to create too many problems. So where do we go from here with the human factors? Where do we use it? In a proactive manner, we should consider humans in safety analysis, such as failure mode and effect analysis. when we're doing these analyses, we don't tend to look at the human part of it. We look at the equipment design or how it works and what it goes on. In a reactive world, we consider human error in accident investigation. This is the easiest cop-out. It's the easier thing to turn around. Well, we have a plane crash. Usually the thing that pops up is pilot error, or we just had the train crash in what was it, Brazil or Spain or something? And they have actually gone straight out to catch the train driver, which in this circumstance is probably right. He probably was doing the wrong thing. But it's a quick thing to blame the human straight away. When in design we could change that sort of stuff. So when we're considering the human error in the systems process, when you look at the failure modes, we should look at slips and lapses. What sort of thing could go wrong if he's operating that particular piece of equipment? We should consider the mistake in his decision-making processes and the fact that he could violate within that piece of equipment. Now I'm going to show an example now of an inadvertent operation, and I'd like to thank Alan Ninnis. Is Alan in the group today? No. Alan was designed an innovation award winner at the Minerals Council's conference earlier this year. And he should be congratulated on a great systematic approach to a task that created an injury to one of his workforce. And what it was this is the guy who was putting a megabolt into the roof, and he hit the wrong handle, and the bolt slipped out and come down and hit a guy onto the hand. Quite a serious injury. And they went through the process. They developed it all, and they designed a piece of a handle where you can't inadvertently let this gripper go. If you hit the wrong handle, it lets the grippers go and the cable fell down. They've designed a piece of gear now where you can't inadvertently push that thing down. And it's a great idea, and it's been transferred across the industry. But the question you would need to ask is, why did they have to do that? Why did they have to go and design that piece of equipment to prevent that accident from occurring? Well, I bet it's happened before, and then if you haven't put this system in, it could probably happen again. So when the engineers are designing this bit of gear, to recognise the fact that this could happen in your design, and then build it into it that you can prevent it, that's error forgiving. That reduces that process there. Then you ask the question about another little thing here. This was the gentleman that had part of his arm amputated by hitting the wrong lever. And what they've done here is they've retrofitted, as you can see just here, a blocking so you can't actually get the wrong land. This is one he has to touch. You can't touch any other ones to stop it. Again, why did they have to do this? Why couldn't that have been put in the design stage of how the accident occurred? This one's an interesting one. Let's see the black arrow and the white arrow, so in whichever direction you're going to, black or white. And this is of an elevated work platform on the surface. And when you get into the platform, if you look at it, there's your black arrow and there's your white arrow. When you're going in that direction, let's go there. Now, if you look at the results of this is human error at its best. This is the platform after it had been used the wrong way. If you see the machine here, that machine can allow the platform to rotate 360 degrees. When you're in this position, the arrow works one way. When you go 180 degrees around, the arrow is reversed. Can you see the human error here? And this is the result. They've just thought it was going the wrong way, and they've pushed it in the other way. So really, it's error provocative, for want of another term. Yet, can that be designed out that doesn't? If you'd imagine you had so many people in the bucket when they're operating it, then the results could be quite devastating. So the future. The importance of human error will need to be recognised. It has to be recognised. It shouldn't be in the too hard basket, which it has been in the past. We tend to think that people can think on their feet and do it themselves. The potential for human error will be considered, or should be considered, in the design phase. It needs to be another way. It shouldn't be the subject of retrofits. It should be designed initially. And human error will be should be adequately considered in part of accident investigations. It needs to be. And finally, this is an old one, but a good one. It's the Larsen process. Well, it's a delicate situation, sir. Sophisticated firing systems, hair trigger mechanisms, and Bob's wife just left him last night, so you know his mind's not into this. That's human error at its best, guys. You wouldn't want to be working alongside the guy. Thank you very much.